So far we have this chapter talk about the correlation, and now we talk about the linear regression. But before I tell you what is a linear regression, it's a good idea to we discuss some basic concept from algebra and what is the equivalent in statistics. Okay, so let's start with some basic algebra. So each one of you must have seen this type of equation somewhere in mathematics text: y equals to mx plus b. You must have seen that. Please allow me to swap these two terms. I will tell you the reason for that. Let me write that. Let me write the b first and the mx later. So we have y equals to b plus mx. This is called the equation of a straight line in slope-intercept form. This is called slope-intercept form. Let me write here. Slope-intercept form. Okay, so let me tell you what are the basic things here. What is y here? Y is called the dependent variable. Y is called a dependent variable. X is called the independent variable. Here M is called slope, right? And B is called y-intercept. So this what you must have seen in if you have taken any math course in algebra, you must have seen y equals to mx plus b. So now what I'm going to tell you, it's in regression and correlation, what form this takes, right? What form this equation takes. Like we have y equals to b sub 0 plus b sub 1x, and we put a hat on the top of that. I will tell you why we put a hat. This is called y hat. Y hat equals to b sub 0 plus b sub 1. I will call this b0 or b0 plus b1. What are these things here, right? Here y hat is called response variable. Is called response variable. X is called explanatory variable. Explanatory variable. B1 is called the slope, and B0 is called y-intercept. So these are corresponding. This is the corresponding equation in regression, right? So if we have this equation in algebra, then we have this equation in regression, right? So you need to remember in statistics we will talk about, when we talk about the equation of a line, I will talk about this type of equation, y hat. I will tell you later what y hat mean. Y read as is like read it like this. Y, this is y hat. Okay, I will tell you what it means. So what is the difference between a y and a y hat? I will tell you later on. Okay, so I hope you understand up to this point. So this is what you need to know. Now let us extend our discussion, and let us suppose, for the sake of discussion, that we have this scatter plot from where somewhere I have this data points, right? And I have drawn a scatter plot here, right? Now what I want from you, I want you guys to think about, can you draw a line which is closest to all these points? Such a line we call the best fit line. Like I'm asking you guys a question, that can we draw a line which is closest to all these points? Or can you draw a line, can you fit a line which is the best fit line? right? So this is possible. Let's say I can do that. Somebody say, okay, no problem, I can do that. Let's say I draw one of the line. Let's say I draw one of the line, and the line is, let's say, something like this, right? Somebody say, no, no, this is not the right line. I have a better line. I think this is the best fit line. I'm trying to change the color. Somebody say, no, no, this is not the best fit line. This is the best fit line. Somebody say, no, this is not the best fit line. This is the best fit line. Now, just look at these four lines, just for the sake of discussion, and just think about it. These are the four lines, and we want to decide which line is the best fit line. But what I mean by the best fit line, which line out of these line is closest to all these points. So what I'm asking you guys, what is the best fit line? Is the best fit line, right? Which line best fit these data points, right? Now, just by looking at these points, you can't decide that. You can't decide that, right? There is a mathematical way. There is a mathematical way of deciding which of these line will be the best fit line. And when I say the best fit line, I already told you that line is closest to all these points, right? So there has to be a mathematical way of deciding the which of these line is the best fit line. And what we are going to do in order to decide that, we show you the concept of residual. Let's see the concept of residual. Now what I'm going to do, I'm going to show you which of these line which I already draw is the best fit line, and let me draw a line which is called a linear regression line. I will talk about that. What is the line? But I'm showing you a line. Look at that. Here is the blue line, right? Here is the blue line, and my claim is that this is the best fit line. This is the best fit line. What I mean by that? What I mean by that, when I draw this line, this vertical distance, this distance, this distance, this distance, this distance, and all these distance, for this line, this distance is minimum from all these data points. Let me show you what I mean by that. Look at that. I'm talking about these green lines. These green lines are called residuals. These green lines are called residual, and what we try to do, we try to minimize these vertical distances, and a line which does that, a line for which these vertical distances, which are called residuals, is minimum, that will be the best fit line, or that will be the line of the best fit, or that the line will be called the regression line. Okay, so note that some of the distances are positive. Note that some of the distance, look at that, my old one. These were my old lines which I talked about earlier, and this is the line which system has drawn. System has shown me, okay, your lines are not the best fit, but this is the best fit line. Why? Because for this particular line, these vertical distances, which I'm calling as a residual, is minimum. But note that these vertical distances, for some the vertical distances are positive. These are positive distance, right? And for these residual, the vertical distances are negative. And what happens if we add up, and if we try to minimize this distance and we add up these residual, the positive one will cancel out with the negative one, and we won't be able to achieve the target. So what we actually do, we try to, instead of minimizing the distance, we minimize the square of the distance. And as a negative number, when we square a negative number, it becomes a positive. And instead of minimizing these vertical distances, we minimize their square of the distances. So a line for which the square of the distances are minimum is called the line of the best fit, or the regression line. So I told you this mathematical criterion for finding such a line for which for which the square of the residual is minimum is called the best fit line, or the line of the best fit, or the residual line. So it turns out that this blue line is our best fit line, or is our regression line. This is the only line for which these square of these distances is minimum. Given age and the price data for sample of 11 Orient cars, you have to do these 7 parts. Draw a scatter plot, compute the value of R, find the regression line or the best fit line, find the equation of the regression line, predict the price of the car whose age is 3 years old, find the value of the coefficient determination. I will explain you what is the coefficient of determination in this problem, and interpret the coefficient of determination, right? The first 2 part I already have done that in my previous video, but for the sake of completeness I'm doing them again. So this is the data given to you, the age and the prices of the 11 sample cars. And what we are going to do, we're going to first draw a scatter plot. So what we are going to do, we're going to go to the insert, charts. Let me first select this. Now we go to the insert, charts, and here is the scatter plot. So this is the scatter plot we have. Right, now what I'm going to do, I do second part, I'm going to compute the value of R, and I hope you remember in my previous video I have computed this value, and this value was computed by using the formula called Coral. So Coral, I'm going to use this function Coral. We go to the formulas, more function, statistical, and I'm going to look the Coral command, C-O-R-R-E-L. That's the Coral command. Excel is asking you where is your first set of value, array 1. Tell Excel this is my first set of values. Now Excel is asking you where is your second set of values. Tell Excel this is my second set of values, and you press OK, and this is the value of R that comes out. Right, R equals to minus 0.923 and so on, right? This is the number. I'm not going to round it. I will show you something in a minute. So I'm not going to round it, although we usually round it to 2 decimal places, but I'm not going to do that. So note that here the value of R is minus 0.923. I told you in my previous video, if the value of R is close to a -1 or a +1, it means there exists a strong relationship. And as the value of R is negative, it means there exists a negative relationship. Negative, strong, but negative relationship, right? What does this mean? What does this mean? Look at this value of R. It is very close to a -1. It's minus 0.923. It's very close to -1. So it means I can say there exists a strong negative correlation between the age and the prices of the car. What does it mean? The smaller values of age are related to the larger values of the price, and the larger values of age are associated with the smaller price values. That's what it means, the negative correlation. So so I hope you are able to understand how we compute it, how we compute that. Now let's compute. Let's find the line of the best fit. Let's see what I mean by that. I click on this plus sign. Let's click on this plus sign, and I ask this Excel to please give me a trend line. Right? When I check this box, a trend line appears. This is the line that appears. This is the line, which is the dotted line shown, which is called the line of the best fit. This is called the best fit line. This is called the regression line, and this line is created by using a criterion which I discussed earlier in the video called the least square criterion, for which the sum of the squares of these vertical distances was minimum. The vertical distances were called a residual. I hope you remember that, right? So this is the line, which is the line of the best fit. This is the line, this dotted line is called the regression line, right? I hope you are able to understand that, how we do that. Now let's move to the part number 4. We have to find the equation of the regression line. So far this dotted line is the regression line. We haven't found the equation. So I ask you guys to, you don't confuse the two concepts. This dotted line is the equation of the regression line, right? This is the equation. And what I'm asked now in the part number 4, I am asked to find the equation of the regression line, right? So don't confuse the line, the physical line itself, with its equation. So how we are going to find the equation of the regression line? What we do, we click on this plus green symbol, we go to this trend line, right? You see an arrow here, you click on this arrow and you go to more options. When you go to the more options, this dialog box appear, and you go to the very last two options. You go to last two options. This first one says display equation on the chart, and the second one say display R-square value on the chart. Let me check these two boxes. I say display the equation on the chart, and you will see an equation will appear here. And the second one is display the R-squared values. I check this box and a value of R-square appears. Look at that. So the top one, this is the equation of the regression line. Let me make it a little larger, and let me change the color also, right? This one, and let me make this little larger, and let me change the color also so that we can draw your attention. Okay, now look at that. So what I have here, I have the equation. This one, the red one is the equation of the regression line. This says y equals to minus 20.261x plus 195.47. This one, this is the equation of the regression line. This is the equation of this line, and this one R squared, this is called the coefficient of determination. I will explain this, what this mean, but this is the R square value. How we get this R square, like what is the relation of this R with this R, I will explain that, right? So I hope you are able to understand how to find the equation of the regression line. Now what we are going to do, we're going to we're now going to see what is the usefulness of this regression line, how this line can be used, what is the purpose, how we can use this equation of regression line in a meaningful way. And for this we are going to this part number 5 will help us. It will help us in making the prediction. This regression equation can be used to make a prediction. What I mean by that, look at that. Look at the age column. You have the price of 2-year-old car. Yes, it is. You have the price of a 4-year-old car, a 5-year-old car. That your table give you the price of 2-year-old car, the 4-year-old car, the 5-year-old car, the 6-year-old car, the 7-year-old car. But tell me, do you find the price of a 3-year-old car? The answer is no. You won't find any price whose age is 3-year-old. So what we are going to do, instead of looking at the value from the table, what we are going to do, we're going to make use of this equation to make a prediction. And we are going to predict that value. This table doesn't give us the value. Remember, this table doesn't give us the value, and these values are called actual values. These y values, these are the x values, and these are the y values, right? These are actual values, these are y values, these are the values given to us in the table. But what we are going to do, we are going to use this regression equation to make a prediction. How we do that? Let's see. Now recall, this was the equation of the regression line which we already obtained. Please allow me to put a hat on the top of that. I will explain you why I'm putting a hat and what is the meaning of this hat. Y hat equals to minus 20.261x plus 195.47. My dear, this value, this minus 20.261, this is called the slope, the B1, and this is called the y-intercept, the B naught. I hope you remember this equation, y hat equals to B sub 0 plus B1x, and this is the same equation, right? You can compare these two equations. They look quite similar. I will explain what is the meaning of this, the slope, and what is the meaning of this y-intercept. But first let me predict the value. So what I'm going to do now, I'm going to predict the value of this price. This is the price value actually, and this is the age. Remember, this is the price of the car, the predicted price, and this is the age of the car. So I told you that in the previous table, there was no price of the car whose age was 3 years old. So what I'm going to do, I'm going to say take x is equal to 3, or take age of the car equal to 3, and we see what is the price comes out. What is the price that this model tells us? So let me do that. Y hat equals to minus 20.261 times 3 and plus 195.47. Let me plug in these values and see what the value of y hat comes out. Y hat comes out to be 134.69 when I round it to the 2 decimal places. But recall that those prices were in hundred of dollar, right? So this is the price 134.69 in hundred of dollars. So I have to multiply this price by 100. So y hat comes out to be 13469, right? When I multiply this by 100 and the decimal moves 2 places to the right side and it becomes this one. So the answer comes out to be $13,469. So this y hat comes out to be $13,469. So this comes out to be, let me correct that, $469, right? $13,469. This is the predicted value of y. This is the predicted value of the price. Predicted value of the price. And this y hat, the hat always represents the predicted value of y. So it's very important that you understand the difference between y and a y hat. Remember, y is the actual value of y, and y hat is actually the predicted value. It's a predicted value, the value which comes to us via this model, and this we have created this model. So this is the value which we have predicted. So the predicted value of y is this one. So you can see that this regression equation can be used very easily for the prediction purpose. We have used this equation for the prediction purpose, and this is one of the use of this prediction, right? This is one of the use of this regression equation, that it can be used for the prediction purpose. Now I will show. Now the question that comes to the mind is that how good is this prediction? So a prediction can be a good one, a prediction can be a bad one. So the question that comes to the mind, how good is this prediction? And now we talk about this. How good is this prediction? Let's see. Before I tell you how good is this equation, the regression equation, in making a prediction, let's see one thing. Let me find the r squared value. Let me square this number. I told you I will keep this. So what I'm going to do now, I'm going to square, or I can do this. I can multiply this number with the same number, right? That's how you square the number. Look at this value. Look at this value. It comes out to be 85 point. Let me round it to, let me reduce the decimal just to draw your attention. Look at that. This value comes out to be 0.8534. And this is the same as this value. R square is equal to 0.8435. So what happened? This coefficient of determination, which I told you earlier in this video, this r square is actually the square of the linear correlation coefficient. So if you square this number, you get this. So if you square the linear correlation coefficient, you get the coefficient of determination, right? This is something which you need to keep in mind. So now we have the coefficient of determination. What is the coefficient of determination? It is the square of the correlation coefficient. So if you square the linear correlation coefficient, you get the coefficient of determination. Now remember, this value of r always lie between 0 and 1. They always lie between 0 and 1, right? And if the value of r square, the coefficient of determination, is close to 1, it means the regression equation is very useful in making a prediction. And what happens if the value of this r square is close to 0? It means the regression equation is not useful in doing the prediction. So I told you that I will explain that how good is this regression equation is in doing the prediction. Again, let me repeat. If the value of r square is close to 0, it means the regression equation is not useful in doing the prediction. So it's not useful in prediction. You don't use this model for doing the prediction purpose, right? But if the value of r square is close to 1, then it means it's useful in making the prediction, in doing the prediction. That's the first use of this coefficient of determination. There is another use. There is another use which is given is here. We get the value of r square is 0.852. If you round it to one decimal place, sorry, r square comes out to be 0.85, 85.3%, right? 85.3%, 85.3%. It means 85.3% of the change in the prices is due to the age of the price. The 85.3% variation in the price can be explained by the age of the car. So this is called the explained variation. Explained variation. I repeat, 85.3%. What I did, I converted that the coefficient of determination, the value of the coefficient of determination in a percentage. And this turns out to be 85.3%. It means that 85.3% variation in the price can be explained by the age of the car. So you might be wondering what happened to the 14.7%. And 14.7%, the rest of the variation, 14.7% variation is called unexplained variation. Unexplained variation. Explained variation. The regression equation is not able to explain this variation. This variation, which is called unexplained variation, this may be due to a random chance, or this may be due to the presence of a third variable which is causing the change in the price and in the age of the car, right? I hope you remember the earlier discussion that sometimes the changes among the two variables is caused by a third variable, right? A lurking variable. I talk about that, right? When I talk about the cause and effect relationship, I talk about that. So the total variation can be divided into two parts. One is called an explained variation and the other one is called the unexplained variation. 85.3% variation in the prices can be explained by the age of the car, whereas the 14.7% variation is called unexplained variation, and it may be due to a random chance or it may be due to the presence of a third variable which is causing the change. So we have seen the two use of this coefficient of determination. Number one, let me repeat that. Number one, it can be used to check whether our equation is a good predictor or is it a bad predictor. And the second one, it tells us what percentage of the variation in the response variable can be explained by the explanatory variable, right? Now look at that. Our value of r square is close to 1. So it means our regression equation, which we earlier discussed, is a good predictor. Our regression equation can be used for making a prediction. So I hope you understand all this stuff. Thanks for watching.